I'm going to start the lesson now. Do you want to take a screenshot of the quiz results? Have you got those?
Yes, I've got them, Mr. Yes.
Perfect. Okay, let's get going now. What I want to do is I want to look at a past paper exam question. And so when I first look at an exam question, I always take some time to orient myself and kind of see what theorems might be involved. So as you look at this question, I want you to tell me what in the chat, or if you put your hand up, what are some theorems that might be involved in this question? Just from what you've read at the top and from quickly looking at the question. I'm going to give you 30 seconds or so to read it. And then I see David has raised his hand. Let's ask David, what theorems do you think might be involved here?
Okay, the theorems I think might be involved is angles at the same segment. It's what I see.
Okay, so sometimes what we call the butterfly theorem could be involved. I agree. You've got a cyclic quad, LKRN, and so that butterfly definitely could have angles in the same segment. Is there anything else that you notice that might be important? Anybody else got a comment? Or often I find students feel a bit overwhelmed when they first see a drawing. And so it's good to take the time to almost introduce yourself. That's what I call it. So, get to know the circle and see how things are going on here. So what else do you notice in the drawing? So Chloe said angle in the semicircle. I think I agree. So I agree. So I noticed that. And yeah, I think there might be other stuff hiding, but I think that's kind of where we're at. Okay, so let's start the question now. The question says, find me LKR, which is basically, it's this bit over here. So LKR, and then find me R. So this is this thing down here. And then find me N, which is this down here. So what I'm going to do is I'm going to let you try and do this by yourself. So I'll give you sort of 2 minutes or so now. If there are questions, please do ask. But otherwise, yeah, just get going with the question and see if you can do it yourself. And then I'll explain as needed. Okay. Oh, I see what you mean, Tony. There are cyclic quads possibly. Although there is a cyclic quad involved, yeah, but it may not be useful in this question. I see people are starting to say that they are pretty sure they know what LKR is. And from what I'm seeing in the chat, I agree with you because I see a diameter. This goes through the center of the circle. It's a diameter. And so we know something about this angle from a previous theorem. We do. Yep. So we're going to say this is 90. We'll say up here, LKR is 90. And the reason is going to be angles or angle in a semicircle. Okay, so this is 90. Awesome. What about R and what about N? I see some good suggestions. Keep those answers coming. I'll give you a bit more time before I say anything. So I agree that angle R must just be 180 minus 58 minus 90, which is 32. And that's just going to be sum of angles in a triangle. So now we're down to finding what n is. And what is n going to be equal to? It's this one over here. And also, what's the reason? So, oh, here we go. Yeah. So, and Isipo and Chloe, I agree, it's going to be 32. And the reason is going to be angles in same segment. You can see the butterfly shape where the butterfly is kind of a cyclic quad. And you can see that this over here is going to jump across to this one over here. Okay. Like what I'm seeing, notice how we've used all the theorems to combine together. And so, yeah, I think it's time for us to move on to question number 2. Well done, everyone. Okay, so here is question number 2. And let's take a moment to introduce ourselves. O is the center of the circle. A, B, C, D, and E lie on the circle such that chord AB and chord DC are equal in length, and AEB equals 39. Before we start the question, just tell me any theorems that jump out at you. They may or may not be relevant, but just interested to know any theorems that jump out at you. And then we'll start the question. And you can pop your hand up if you like, if that's easier and quicker. Or you can put it in the chats. Okay, so a couple of things that we're observing as we introduce ourselves to the drawing is radii. Yep, I definitely see radii. I see angle at the center is twice the angle at the circumference. I don't know if I see angle subtended, but oh no, here you are. So, okay, I do see these are interesting. I'm remembering something about a theorem. So, yeah, so and I see angles, equal chords, equal angles, or angles subtended by the same chord. I think the reason that we normally use is equal chords, equal angles, but that is something to bear in mind as we go into this question. Okay, so let's start. The question is asking you, what is O1? So that's O1, and what is O2, which is this here? And I want you to work that out for me now. Okay, so Dawn, equal chords, equal angles. So what it means is if you've got a circle and you've got a chord here and a chord here, but they are the same size. So we'll normally have it like that and like that. If those chords subtend an angle at the center or at the circumference, they're going to be equal in size. So basically, this angle over here will be equal to that angle over there. And it's almost like you slid the triangle around basically to get to that. So that's equal chords equals equal angles at the center, but you also get equal chords or give you equal angles at the circumference. And so you can imagine the same sort of drawing. You have two equal chords and they make an angle at the circumference. Yeah. Then those two angles will be equal. And we just say equal chords, equal angles. Yeah. So I hope that was helpful. And then that may come up in the question. I haven't done the question yet, but yeah. Subtend means to basically, subtend an angle is almost like be the base of an angle. So if we think of this chord subtends or is the base for this angle that goes up here. Oh, sorry, my scribbling is horrible here. Does that make sense? So it's almost like the green bit is the base, and then it allows you to build the angle that goes up here. All right, let's have a look. So what is O1 going to be equal to? O1 is equal to 78 degrees. O1, not Q1. So O1 equals 78 degrees, and that's angle at center equals twice angle at circumference. So do they tell you that the chords are equal, or is it something you should be able to see? I suppose they could do either, but normally they show it to you using this link here. Can you see that? That sort of, it looks like the cat's whiskers or something. And those two chords are equal. And so that kind of is a little bit of code saying that this angle over here, and this angle over here are going to be actually equal to each other, which kind of gives the answer away for O2, doesn't it? So what's the answer going to be for O2? Well, let me check my answers, but that's what I would say. Yeah. So it's 78. So basically, double 39 gets you 78 for O1, although the drawing looks a bit weird to me. It's almost like but mathematically, this is going to be 78 on the one side. Get that? So this is going to be 78, and then this is going to be 78. And the reason for the second one is going to just be equal chords, equal angles. So for a question like this, would we need to prove congruency? No, you're using a theorem. We only use congruency really in proofs most of the time. So you wouldn't need that for this one. Okay, I think it's probably good to move on to another one, but let's just see. Yeah, just give me a thumbs up if you followed most of the thinking. I know a lot of you got caught by that equal chords, equal angles theorem, but hopefully I've explained it a little bit enough. Yeah. Okay. Cool. Okay. Party on, party on. Okay, so next question. I want to take a bit longer to introduce ourselves in this one. So what it says QS and PR are diameters of the circle with center O. So that's something useful. PQ is parallel to SR. This is produced and N is a point on the circle such that Q1 equals Q2. Now, if I look at the drawing, I want to go and find Q1 and Q2. Now, normally they indicate this for me, but in this situation, they haven't indicated. So just to remind myself that these are actually equal, they've given that to me. I'm going to put two little dots like that. And then it says S1 is 48. Now let me go and find S1. Oh, here it's hiding down here. So things are a bit more complicated here. Just tell me, or maybe we don't even need to tell me what theorems. Let's try and find, let's start. Well, just think for a moment. Take 30 seconds to think, what are the theorems that might be involved? And then once you've thought about that, have a crack at finding Q1. So I want you to find Q1. Lesego, yeah, what is your question? Let's go to you. Can we unmute Lesego? Lesego, can you hear me? What's your question? So And Nasipo, I'm looking at the drawing and I don't see a tangent right now. All I see in the drawing, there is this line over here, but it feels to me more like I see a butterfly. I also see like a cyclic quad, like there's a cyclic quad going on. I see the diameters. So there's a lot going on in here, but I don't see tangents. It feels to me like it's more group 1 and group 2. Okay, Lebo, I will make you co-host, yes. Let me go and find you. Where are you hiding, Lebo? Oh, there you are. More. I'll even make you host. How's that?
Thanks, Mr. Is.
No problem. Okay, so quite a few people. Oh, sorry, Lesejo, I don't know what happened there. So some people are saying Q1 is equal to 42. Maybe it is, maybe it isn't. Let's have a look at where Q1 is. So, in fact, what do we actually have to work with in this question? So we know those two are equal. We have the tangents, or we have the diameters, okay? It feels to me, I don't know if I would get 42. I'm wondering, the only thing that we can connect at the moment is I see this 48 over here, and Q1 seems to live over here. So I'm just wondering what connection can be made. Are there raised hands? Let's have a look.
We have Lesejo.
Lesejo, what do you think, Lesejo? What are you noticing in this question?
Sir,
Yeah.
because QPSN is a cyclic quad and ST is basically an exterior line, that means 48 is equal to Q, because of exterior angles of a cyclic are equal to the opposite interior. And then you have to divide Q in half because Q1 and Q2 are equal, which means Q1 is 24.
Yeah, and Younger agrees with you. So let me just write out what you were saying. Q1 plus Q2 is equal to 48 degrees. And the reason is exterior angle, cyclic quad. And then what you're saying is you're given Q1 is equal to Q2, and that was given. And so you know that it's 48 in total, which means that Q1 by itself must just be 48 divided by 2, which is 24 degrees. Very good. That was a bit sneaky, huh? So well done, Lesejo. That was great. Let's see if we can find R now. So R is down here. So let's see if we can find R, and let's take some time to try and do that. What other information might be helpful in this? Maybe we should write in what we found. So we know that this was 24 and this was 24 according to the working out that we've done. So can we connect that 24 to my pink thing down there? Yes, okay. So Nizole, let's go to you. Can we unmute Nizole, Lebo?
Yes, Mr. Is.
Awesome. Nizole, what do you think to get R? Or is it a question? So Nizole, you'll see a little mute button pop at the bottom, and you just unmute yourself, and then you can go from there.
He is unmuted, Mr. Is. I think there's a problem with his audio.
Okay.
Though.
All right, then I'm going to move ahead with R and just see if we can get R. So I think R is 24 degrees. And the reason I think R is 24, oh, what have I done there? So R is 24 because it looks to me like a butterfly. It looks like this one and this one are related in the sort of the angles in the same segment shape. And so we would get angles in the same segment would be our reason. So angles in same segment. Okay. Last part of the question. What is M1 going to be? So M1 is this bit down here. And I want you to think about what are some of the things you've used? What are some of the things that you haven't used? Maybe there's something that we can still use. But I'll give you a bit of time. Yeah. Katlego, let's go to you.
So M1 equals to like angle Q as a whole because of corresponding angles.
Yes, I think you have spotted it. So it's like the F shape, isn't it? Like back from grade 9. Can everyone see? I agree. So I think it's once you spot the F shape, these are parallel lines. And so what did you get for M1 in the end, Katlego?
48 degrees.
48 degrees, yeah. And the reason would be, do you know what the reason would be?
Corresponding angles, huh?
Okay, so corresponding angles, and then we just write down that PQ is parallel to MS. And it will be 48. Yeah, spot on. That was well hidden though. Can I explain R again? Okay, let me do that. So if you look at this drawing, the biggest thing is to see the shapes. And so let me just take away the corresponding, oh, maybe that's gone already. I'm moving other stuff. Okay, so in order to see R's answer, what you want to see is that basically those two angles are in a butterfly together with the cyclic quad. And that's how R is 24. Okay. Awesome. Okay, it is half time. And you know what that means? It is time for a stretching break. And so what I want you to do is I want you to turn on your cameras. I want to see your lovely faces, and you're going to join me in a stretch. Because we are humans, and humans need to stand, and they need oxygen, and they need all sorts of things. So let's stand up and turn those cameras on so we can see you. And Lebo, are you with
Please
me?
join us in the stretch, guys. Yes,
there we
I'm
go.
still here with this.
Just checking.
We'd love to see your faces. Turn on your cameras. Give your mind a break.
Yo, fantastic.
Shout out to Nizole, Shisana, Lesego. Don't be shy, guys.
I'm getting so into this, I'm going to do leg ups here. Yo, there we go. Come on.
Your body will thank you.
This is a matter of very great importance. The productivity of your maths learning for the next half an hour depends on your ability to
It will
stretch.
double after this. Shout out
Yo.
to David. Yes.
Oh, double click. Yo. Stretch it out, guys and girls. Who's giving the best stretch today? I can't see all the videos because of my small screen, but who's giving the
I think
best?
Shisana is going way in
There we
the.
go. Yeah. Oh, I feel like a changed person. I can't tell you how fantastic that stretch was. I hope that your stretching experience was as magnificent as mine. So let us do a brain break, because we need to let our brains, there we go. Okay, so here is today's brain break. You have to tell me what a clock plus bananas times this funny thing in the corner is here, and I will let you indulge yourself now. Okay, so people are funny fruit things. They are funny fruit things. So I agree from the chat that whatever this is 15. So that's kind of helpful. And that the bananas are going to be 4. And then it means the clock must be 3. So what is my final answer? Oh my goodness, people are just smashing it out the park. It is indeed, so 4 times 15 is 60. And then 60 plus 3 plus 4 is going to be 67.
Nice one, guys.
Aha, see how you do raise an important point. It is possible that if you dispute the size of the bunch of bananas, then another possibility for an answer that is legitimate could be 3 plus 3 plus 3 times 15, which would give you, because there was 3 for that, 3 for that, another possibility, depending on how you classify your bananas, is going to be 51. Oh my goodness, is the clock involved as well? Oh my goodness, no, that's too much thinking. Okay, brain broken on the brain break. Okay, no, that's fine. We've had a little bit of our fun, so let's. But I'm impressed by everybody's attempts here, and I think the main logic of this was we were feeding from one thing into the other and understanding how they were interrelated, which I'm pretty happy with. But I'm impressed by your detail-orientedness.
Yeah, you guys are sharp.
Sharp. Okay, quick little stretch up, and then we're going to go into part 2. So let me shrink this a little bit and let's have a look. Okay, so you can see that the drawings are getting a bit more complex. And when I first look at this, I take some time to introduce myself, and I see basically I have 2 circles that are interrelated. And then let's go and look at the drawing or at the writing. So it says PQ is a common chord of the 2 circles. So where is PQ? PQ is hanging out over here. The center M of the larger circle lies on the circumference of the smaller circle. So if I'm looking for M, here is M over here. PMNQ is a cyclic quadrilateral in the smaller circle. So PMNQ, here's P, and where is M? I don't see an M right now. Oh, there it is. It's hiding here. NQ is a cyclic quad in the smaller circle, which I can see now that I've put the dots in. QN is produced to R, a point on the larger circle, all good. NM produced to the chord, okay, that's just more wordy. And P2 equals X, which they've shown us over here. Okay, so we've taken some time. Now, obviously, it's harder to do this when you're under pressure, but I always think take some time to introduce yourself. Now, before we start, what theorems do you think might be involved in this question? Just as we throw out, or even what groups, just so you kind of, your brain is almost retrieving some information. What theorems might be involved here? So some suggestions are tan chord. I haven't seen a tangent yet. Was there a mention of a tangent? Cyclic, quadrilateral. I don't see a tangent. So I think I'm more on the exterior angle of a triangle, opposite angles of a triangle. There is a center of the circle. So someone's mentioned center of the circle. So that might be important. There are chords. And are there any things that are equal? So it feels like we're more living in group 1 and group 2 questions. So questions about circle in the center and cyclic quads are are kind of where my brain is starting to go. But let's start the actual question. So as we do this, I want you to try and find me. You have a reason why N2 is equal to X. So here is N2, and here is X, or P2. Why is N2 equal to X? But PQ is not a diameter. It doesn't go through the center of the circle. It's a common chord to both of these things, but it's not actually a diameter. Aha, Loretta and Shoshana, I think you're onto something. I think that you've spotted that the smaller circle, the blue dots, the cyclic quad. So here's my exterior angle. And here, and it's a little bit hidden, but can you see it's a cyclic quad on the smaller circle? So I agree with you. I think that N2 is equal to X, and the reason is exterior angle cyclic quad. So basically this over here is X. Give me a thumbs up if you can see that. I know it's a bit hidden, and this is where the drawings, the cyclic quad is on the smaller circle, not the bigger circle. All right, awesome. You're with me. Okay. Next question, it says, oh, what happened? My thing disappeared. Come back. Write down another angle equal to the size of X and give a reason. And this is where I'd love you to put it in the chat or to raise your hand. Find me another angle equal to X. There are some comments already flying in the chats. I want to see reasons.
We have a hand from Romeo.
Romeo, go ahead. Unmute Romeo and then tell me what you think.
Q1 is equals to X because MQ and PM are equal to each other. Reason being, they are both the radii of the bigger circle.
Perfect. And it's yes, you're right. Oh, it's quite hidden, hey? So yeah. You are quite right. The Q1 is equal to X. And the reason is radii. And it's quite well hidden. Like if you think about this line coming from the big thing, and then this line over here, these are radii. And that's why we know that that would be equal to that. That was a good spot because it's quite deep in the woods there, that one. Okay, now, next one. I want to know, determine the size of R in terms of X. And notice how I'm always using visual prompts to help me understand the question. I'm always giving my brain a break by making sure I know where is R. Okay, I've written my X's in. Find me R in terms of X. Okay. I see, is that a hand that we have there?
Yes, Mr. S. Romeo.
Okay, now let's go ahead. What do you think, Romeo?
I think I'm wrong. But,
okay, give it a go.
Yeah. Since P2 and Q1 are equals to each other,
yes.
Right? Actually, those X's don't really have much to do with how I find the answer, but then you can use the theory of angles at circumference is 2 times angle at the center.
I think, Romeo, you want to get this one, don't you? Is that what you want to get?
Yes, yes.
Okay,
yes.
what would you give that one as a as an amount, or what do you think that's going to be?
It's going to be 180 minus 2x.
So 180 minus 2x. Okay, so
Yeah.
that's a start. And how are you connecting that to R? I think I agree with you. So you spotted
Yeah.
that, eh?
Yes.
And then it's like, because you said something about angle at the center, twice the angle at the circumference. Is that what you were talking about?
Yes, yes, yes.
Okay, so what do you think R is going to be then?
It's going to be 180 minus 2x over 2.
Yeah. So 180 minus 2x over 2, which is actually going to be 90 minus x.
Yes.
That's a toughie. Now, I haven't put all the reasons. The reasons would be sum of angles in a triangle, and then angle at center is twice angle at circumference. And then you get 90 minus x. Oh, and I see everyone is with us. Loretta, Lebo, looking good. Okay, last one for this question. Prove that PS is equal to SR. So prove that PS is equal to SR. Oh, I mustn't rub that out. I'll rub this out. Let's just make sense of that question. Prove that PS is equal to SR. So I basically want to prove that this one here is equal to that one there. Any ideas? So I am having a bit of a flashback. Yeah. So I'm thinking this little line that comes from here. I remember a theorem that says if a line from the center is perpendicular to a chord, it cuts that chord in half, hey? Right? So I need to show, if I can show that this angle over here, this S2 is 90 or S1 is 90, then by that theorem, I've proved that they're cut in half. So now the question becomes, how do I try and find what S2 is? Any ideas, or what connections could we maybe use?
I think Younger has an idea, Mr. S.
Okay, let's unmute Younger. Yeah.
Hi, sir.
Hello.
Sir, I'm not sure, but then I think that S2 is
Yeah.
equals to angle P.
Angle P.
P.
Okay. How do I get that? I don't see that. I sort of see a quadrilateral, but I don't see a cyclic quad. But I kind of get what you're going with, but I don't agree at this stage. Nizale has said the angle of a triangle. So I was thinking, what if we went 180 minus x minus 90 minus x? So what I've done is I've said, I'm taking away this angle and I'm taking away that angle. And that makes sense because of the sum of angles in a triangle. So then what are we going to get for S2 then? We're going to get 180 minus x minus 90 plus x, which means S2 is 90 degrees. And if S2 is 90, that's exactly what we wanted, then we know that PS is equal to SR because line from center perpendicular to chord. And so basically, because we've showed that this is a 90-degree angle, we now know that that one is equal to that one, which is what it was asking. So they actually used a lot of theorems in this question. And yeah, it's a pretty, that's getting tougher. Are there any questions about this question that you'd like to clarify, or just give me a thumbs up if you're generally feeling okay and you might have found this tough, but you followed what we were doing and you can kind of see what we were doing. Okay. Awesome. Let's try and squeeze in. Yeah, no, I took it up a notch now. This is a bit harder. Let's go and try and squeeze in one more question for today. So, okay. So I'm going to give you this question. I'm not going to say anything yet. All I want you to do initially is find me what R2 is. You can introduce yourself in this question. Remember to provide me some reasons, eh? So if you can, or
Mr. Is, we have a hand from the Sicho.
yeah, unmute. Let's go.
Sir, so because the two tangents are meeting at a singular point, that means R2 is equal to Q2, and that makes a QRP isosceles triangle. So you can say angles of a triangle 180 minus 70, and then divide that answer by 2, and you have R2 equals 55.
Yeah, love it. So the way I would write out what Lesego just said is R2 equals Q2. And the reason for that is tangents from a common point. And then, so we know those two are equal. And we also know, so basically, if I make that X and that X, we also know that then 2X plus 70 is 180 because of the sum of angles in a triangle. And I suppose here I should say, let X equal those ones. And then if I solve that equation, I take away 70 from both sides, divide it by 2, and I get 55. You didn't have to write it like that. I'm just showing you a way you could have written it. But I agree, it's 55. It is 4 marks though, hey? So you need to give 2 steps and at least 2 reasons. Generally, you would probably get the mark allocation would be that. Okay, try and find me Q1. Let's try and do that next. Is there a hand up?
We have a hand from Romeo and Virgilio.
Okay, Romeo, let's go to you. And then Figelo.
I think what the first thing we can notice is that there is a radius in so 2 sides of the triangle MRQ. And the rule we know is that when a line from center is perpendicular to a tangent, which means that that angle there, Q1 and 2 is equals to 90. So because we already know Q2, we'll just subtract 55 from 90, and then we get 35.
Yeah.
As Q1.
So, yeah. So basically what I think you are saying, and I hear you, is that MQP is 90. Can you give me the reason for the theorem? Or what's the thing?
Like I said, it's line from center meets tangent,
Oh.
like it's is perpendicular to the tangent.
Okay, so the shorthand name for that is just tan perpendicular to radius. We just say that, tan perpendicular to radius. And I agree with you that you know what Q2 is. You've worked out Q2 already. So Q2 was 55. Therefore, Q1 would just be 35 degrees because you subtract the 55 from the 90. There was another hand. Well done. That was good. Wasn't there a question?
It was pretty
Yeah.
low, but she put it down.
Okay. All right. Last bit. Can we find what M2 is? So we know what Q1 is. Q1 was 35. Now we're trying to find what M2, which is over here. What's that going to be? Yeah, whose hand's up there? You're on fire today. Is that Romeo?
Romeo.
Oh, sorry, I think I clicked the wrong button. Romeo, can you put your hand up again? I think I hit the wrong button.
No, it's okay. It's okay.
Okay, here we go.
So first thing we need to do is find the sum of angles in a triangle. So
Okay.
the triangle MRQ is similar to triangle SMV. That's the first
Okay.
thing we notice, right?
Yes.
And the theory we're going to use after we find that angle, is it M1? So we need to find M1, and to prove that M1 is equal to M2, we're going to use vertically opposite angles.
Is that, let's just check that the angles are vertically opposite. To me, if we were going to use vertically opposite, it would have to be keep going like that. Does that make sense? So I think you're on the right track, but I don't think you can use vertically opposite. But I like your argument, which I think is saying that must be 35 because of radii. So what would M1 be?
It would be, let me just, 110, yeah.
Yeah. So I'm not going to write in all the reasons now, but that's going to be 110. Now, what I want to know from someone else is how do I connect the M1 to the M2? And I see Leseko's hand is up. Maybe Leseko has an idea.
So from earlier on, I remember that equal chords subtend equal angles. So because SV is equal to RQ, that means M1 and 2 are equal to each other, which means M2 is also 110.
Yeah, so basically what we can say is M2 is 110, equal chords, equal angles. And the equal chords that Leseko is talking about is there is the one chord, there is the other, and then the angle that they're making is here and here. Sorry, that was a bit messy.
Mr. Ace, can you please explain again why they can't be vertically opposite? Because some students are still saying that in the chat.
Okay, so vertically opposite, you have to have two sort of swords like that are going straight. And then you could have like this angle is equal to this one is equal to this one. The problem is this line is not a straight line, it's bent. And so you can't use the justification of vertically opposite because these lines don't qualify as being vertically opposite. You have to use the fact that the chords are the same. And so they equal chords, equal angles would be the correct way to write it out. Let me just bring up the formal memo just so we can look at how they write it out here. Yeah. So yeah, there we have the thing there. Okay, equal chords, equal angle. Equal chords subtend equal angles at the center. So yeah, no, that's fine. So we have that one there. All right, guys and girls, I'm going to call it there for today. Just to let you know, next week, we're going to continue with paper 1 revision. And so I do hope to see you there.